We have one other way that we can talk about an interval, and that's through using plus or minus notation. So for example, if I'm looking at this interval 1, 3, which we often will call an open interval, it doesn't include the endpoints. What we could do is try and consider what the middle value is between those endpoints. So we're looking at 1, 2, 3. So my picture is this: open at 1, open at 3, and all the numbers in between there. So if I look at the picture, you can clearly see that 2 is our midpoint. Okay, that's our middle. And then what we can see is that if this is the middle value, then we're equal distances on the left and the right, which happens to be a distance of 1. We call that a margin of error. So the margin of error, or distance from midpoint to endpoint. And the way that we would write down our plus minus notation for this particular interval 1, 3 is to say that we have 2, this is our midpoint, plus or minus the distance that you would move to the right and to the left to get to your endpoint. So in our case, it's 1. So the way that we could convert that back into an interval is to say, okay, well, 2 minus 1 gets us one endpoint, and 2 plus 1 gets us our other endpoint, which would be 1, 3. So it was clear in the picture to see where our middle was, but basically when you're asked to find the midpoint, you're really looking at the average of the endpoints. And then our margin of error is really just the distance between endpoints cut in half. So for example, let's look at this interval 1, 9. If I want to look at the middle without actually drawing a number line and trying to count and see where the middle is, I can say, okay, well, let's look at the average of the endpoints. To find the average, I'm going to take the endpoints 1 and 9, add them together, and divide by 2. That gets me 10 over 2, which is equal to 5. That's going to be my midpoint. Then if I want to find the margin of error, I'm going to have to take the distance between those endpoints. So to see the distance between them is really taking 9, subtract 1, which gets us 8. Then I'll have to divide that in half, which means to divide by 2. So I'll have 8 over 2, which is equal to 4. So that's my margin of error. So then I would write my plus minus notation starting with the midpoint, which is 5, and then write plus or minus 4, which you can clearly see that this would get me the interval we're talking about, because we'd say, okay, well, to get to the left endpoint is 5 minus 4. To get to the right endpoint, we add the 4. Right? You start with your middle, and you have to move left 4 spaces and right 4 spaces. That gets you your endpoints, which is 1, 9. We'll try one more here. If we're looking at this interval from -1 to 4, again, you could draw it and try and see where the middle is, but it's not always so exact. So for this example, if I want to find the midpoint, I'll look at the average. So I take -1 plus 4, divide by 2. That's 3 over 2, or we could even say 1 1/2. Then for the distance, or the margin of error, I want to see how far -1 and 4 are from each other. Well, that just means we're going to take 4, subtract off -1, or you could even count 5 spaces there, then cut that in half. That's 5/2, or we could say 2.5. So our plus minus notation, we have 1.5 plus or minus 2.5. So again, this is our midpoint. And we add or subtract the distance, which is our margin of error, in order to get to our endpoints. So just to kind of check that again for us, we have 1.5. If we move to the left, we're going to subtract 2.5. Then we'll take 1.5 and move to the right. Okay, which 1.5 minus 2.5 would be at -1, and 1.5 plus 2.5 would put us at 4, which gets us the interval that we want. Now try this problem. Given that you have the interval 3 to 10, what is the midpoint?